My problem says sketch the graph of f of x, which is equal to 3 times sine of pi on 4 times x minus 13 pi on 8, then plus 5. I know what the graph of sine of x looks like, and I know how changing the formula affects the shape of a graph. So I reckon I can do this by starting at sine and then investigating this bit more. So this is what sine of x looks like. It goes up and then down and then up again. It does the same thing back here. Maybe not quite that high. And the height that it gets to is 1, and the depth that it gets to here is -1. It takes pi to get up and down again, and then another pi to go down and up again and get back to where it started. That's a period of 2 pi. And we go back minus pi, and then all of these things happen at the halfway marks. So this would be half of pi, which is the same as pi on 2. This would be 1.5 of pi. This would be -1/2 of pi. Okay, so that's y equals sine of x. So now I want to look closer at my formula here. So the 3 times this would multiply everything by 3. And so that would become 3 and -3. It's not to scale anymore, but that's okay, I can fix that later. And then on the outside, I've also got a +5, which is going to shift it up, but I'm going to deal with that later. It's easier to deal with the stretchy things first. And then this pi on 4 should be stretching it. Oh no. When I do things on the inside, I have to think about it as replacing the x with something. And to get to this, first I'd replace the x with x minus 13 pi on 8, and then I'd replace the x with the pi on 4 times x. So this bit would shift it, and then this bit would stretch it. But then because I stretched it out, the amount I shifted it by would change. So it's going to be really hard to keep track of. I'm much better at it when it's written in this form. Like that. So if I factorize out the pi on 4, it'll be easier to keep track of that. So if I divide this by pi on 4, that'll work. So that'll be putting a pi on the bottom and a 4 on the top. So dividing by pi would make it 13, and then the 4 dividing by, that would give me a 2. So let me just try that just to make sure it's working correctly. Pi times 13 is 13 pi, 4 times 2 is 8. Yes, if I multiply this out, it is the same thing. So I've dealt with that, and now I'll deal with this. So timesing by pi would do the opposite here. It would shrink this in by dividing by pi. So this would become 1. This would be a half. So everything divides by pi, right? And then the dividing by 4 would stretch it out. So times by 4, that'd be a 4. Half times 4 is 2. That'd be 6. That'd be 8. That'd be -2. That'd be -4. Okay, so now I can deal with the shifting. The -13 on 2 would shift it forwards by 13 on 2, and the +5 would shift it up. I'll just mark these points so it's easier to see what's going on. So 13 on 2 would be 6.5, because 12 on 2 would be 6. So we're going to have to move this forward to 6.5. Okay. Cool, and then we have to move it up 5. So that's up 3, and then about there. That's 5, and this point is here at 13 on 2. Okay, I'm going to need to know what happens back here, but I guess I can just keep counting things in terms of the peaks and troughs. All right, I reckon I'll draw the graph now. So according to this, the whole graph happens up in this corner. So, well, I mean, there's stuff here too, but nothing below here. So I reckon I can just have it all the way over here like this. So we need to go up to 5 and then another 3. So that'll be 8. And we're going all the way to maybe 10 or 12. That'll be enough. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How about that? And we'll go back a few as well. Okay. So the midline was at 5. 1, 2, 3, 4, 5. That helps me draw it very nicely. And then it started at 13 on 2, which was 6.5. 1, 2, 3, 4, 5, 6.5. No, 1, 2, 3, 4, 5, 6.5. That's there. That's this point here. Might put them in. Okay, and then it goes up here. Now, the original one, it took 2 to get to the peak, and it's still going to do that. So 1 would be here, and then 2 would be there. And so that's the peak, which would be 3 up, and that's up at 8. And then another 2 would get us back to here. So 1, 2 be there. That's far enough, I reckon. And let's go back this way. Another 2 this way. 1, 2 would be down at the bottom this time. And then another 2, 1, 2 would be back at the center. And then another 2, 1, 2 would be at the top again. Another 2, 1, 2 would be down at the bottom. And then another 1, 2 would be down there. I think that's good enough. Cool, I reckon that's good enough. But I also think that I should probably write down a few features of this graph so that anyone reading it knows definitely exactly where it is, even if they can't read my squiggles there. So what features? The midline was y equals 5, and the amplitude was 3, goes up 3 and down 3. The period was 8, wasn't it? It took 8. We got to 8.5 down to 1/2, yeah. And then the phase shift. So we move forward 13 on 2, but that's not very far from moving all the way to the end of the original period, which was at 8. So I reckon technically it's probably better to do it as a smaller shift backwards. It's tradition for your phase shift to be the smallest number you possibly can. So a shift forward of 13 on 2 would be the same as a shift backwards of 1.5 according to the graph. So -3 on 2. I'm just going to check that. 8 minus 13 on 2 would be 16 on 2 minus 13 on 2, which is 3 on 2. And it is a shift backwards, so it's a minus. Okay, I've managed to draw the graph.